Hello friends, welcome to Susan and John MathTube. In this video, we're going to learn about asymptotes. And this video is made exam point of view. So we'll be learning only about the asymptotes of implicit functions. That is, a function in which x and y are all mixed up. And we'll be going through a procedure, not too much into the logic. Okay. Anyway, a small introduction. If you look at the function y is equal to 1 by x, you can use a graphical software and check the graph. The graph goes like this, and it's very easy to observe. 1 by 0, it will be infinity. So at 0, the height of the graph is infinity. 1 by 1, that is 1. So the graph was at infinity and it crashed down to 1 when it moved from 0 to 1. So a graph which was at infinity crashed down to 1, and then if you plug in 2, it will be 1 by 2. If you plug in 3, it will be 1 by 3. And look, the height of the graph keeps on decreasing. So you'll have a feeling that it is going to touch the x-axis. But it will never ever touch the x-axis. And this situation is called, or we can say, the curve becomes an asymptote. So you can imagine an asymptote in two different manners, like the distance between the curve and the line decreases. The x-axis is a line, so the distance between the curve and the line decreases, but they never meet. Or in other terms, we can say that they will meet at infinity. But infinity is not included in the real number system, so you're never going to see that they're going to meet. So, and there are three types of asymptote. One is vertical asymptote. So it's kind of like this. And another is horizontal asymptote. And the third one is there, that is called oblique asymptote. So let's say this is a line. And imagine a curve going like this. So this is called oblique asymptote. So there are three asymptotes which you can expect. Here you can see both the cases, horizontal and vertical. Anyway, since it's your exam time, we'll jump directly into the method. Just a method. I'm not going to explain the logic, just the method. Your expression will be an algebraic expression in x and y, basically an implicit function. The first thing you should check is you have to find the degree. I hope all of you are having a pen and a paper. Please note these points. Because I'm teaching a procedure, it's better that you note all the points. Okay, so the first thing you have to note is the degree of the function. Degree means the highest power available. So you note the degree. Generally, I'm going to write the degree as n. Now what you do is, you have to check whether the expression has x power n, like terms like what you call y power. Maybe it'll be like 5x power n plus 3y power n, etc. Check whether the expression is made up of x power n and y power n. If x power n is present, I'll put a tick mark. If x power n is present, horizontal asymptotes are absent. Please note it. Now, if y power n is present, vertical asymptotes are absent. Similarly, the reverse. If x power n is absent, horizontal asymptotes are present. If y power n is absent, vertical asymptotes are present. And another thing you should remember is, total number of asymptotes in a graph. For example, you saw that our 1 by x has two asymptotes, one vertical, one horizontal. So the total number of asymptotes in a graph can never exceed the degree. So look at this, you should note these points. Point number 1, find the degree. Point number 2, check whether your expression contains x power n, y power n. And the conditions, if they are present, what will happen? If they are not present, then what will happen? And the third thing that you should notice is the total number of asymptotes will never exceed the degree. That is, horizontal asymptotes plus vertical asymptotes plus oblique asymptotes should be less than or equal to n. Horizontal asymptotes are obtained by equating to 0 the coefficient of highest degree terms in x. I'm sure those who are learning this topic for the first time may not understand what this means, but when we do the problems, you will understand. Okay, similarly, for theory's sake, please note it. And vertical asymptotes are obtained by equating to 0 the coefficients of highest degree terms in y. Okay, now the third case, oblique asymptote. Look at this, you saw that our horizontal asymptote will be always parallel to the, kind of like parallel to the x-axis. And the vertical asymptotes will be parallel to the y-axis. And oblique asymptote means it will be parallel to any random line. So, whenever you start finding oblique asymptote, the first thing you have to write is, let y equal to mx plus c be the oblique asymptote. So remember, oblique asymptote means a general line which becomes a tangent at infinity. Or there will be a curve which is very near to the line and the distance between the line and the curve will be almost 0. But they never touch. Okay, so we start like this. Let this be the oblique asymptote. Our job is to find m and c, and from derivations, you can refer any book you like, you can check the derivation. And I'm making this video just because your exam is very nearby. Otherwise, I could have provided the logic behind the formula I'm going to write. Anyway, we have to find m and c, and we'll use a few equations for that. The first thing is phi n is equal to 0. And the second equation is c by 1 factorial phi n dash plus phi n minus 1 is equal to 0. The third equation is c square by 2 factorial phi n double dash plus c by 1 factorial phi n minus 1 dash plus phi n minus 2 is equal to 0. And it keeps on going like this, c cube by 3 factorial phi n triple dash, etc., 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 etc. And I'm sure you didn't understand anything, but when we do the problems, let's make these things very clear. So let's do one problem. This was asked in 2074 Ashwin. So the question is, find all possible asymptotes for the function. Find all possible asymptotes for the function y cube plus 2xy square plus x square into y minus y plus 1. The first thing to do is, you have to move term by term. Remember, term means separated by plus or minus. And you can see that 1, 2, 3, 4, 5. There are 5 terms. And you roughly note the degree of every term. Okay, degree means power. Okay, 3. And if it is a product of variables, degree will be sum of the powers. So degree 3, degree 3, degree 1, degree 0. Constant term means degree will be 0. Anyway, the degree of the expression, degree of this expression means the highest one which you found. So I am going to write degree of the expression is equal to 3. Okay, that is step number 1. The second thing you should check is x power 3 present or not, and is y power 3 present or not. So you can see that x power 3 is not present and y power 3 is present. And do you remember what I wrote earlier? If x power n is present, horizontal asymptotes will not be there. If y power n is present, vertical asymptotes will not be there. Anyway, here x to the power 3 is not present. So what does it imply? Okay, horizontal asymptotes are present. And what does this imply? Vertical asymptotes are not present. Okay, so the first thing to do is you have to find the horizontal asymptote. Okay, earlier I wrote something, I think it's in your notebook. So to find horizontal asymptote, what we do is we find the highest degree terms. Let's see, highest degree term in x. No, this is the highest degree term in y. And here the highest degree is 1. Here the highest degree is 2. Yeah, this is the one. So look at this. I'm looking term by term, and I saw that the highest degree for x is available in this term. And the highest degree that is available is 2. What is the highest degree available here? 2. Okay, now tell me the coefficient y. So what is the highest degree term available in x? Y. So the horizontal asymptote is y is equal to 0. Y equal to 0 means our x-axis. So once more I will tell you, to find the horizontal asymptote, what you do is you collect the highest degree terms in x. Or rather, we look for the coefficients of the highest degree terms in x. Okay, now horizontal asymptote is done, and we know that there will be maximum 3 asymptotes, so we have to go for oblique asymptotes. Now what we do is we write, let y equal to mx plus c be the required oblique asymptote. Okay, so our job is to find m and c. Okay, now comes a few quantities, phi 3, phi 2 and phi 1. So there are 3 quantities, phi 2, phi 3, phi 1. Okay, phi 3 means, we'll scroll up, take a look at the question. Okay, look at this. What is the third? I'll do one thing, I'll shade this for you. Okay, degree 3, degree 3, degree 3. Now what we do is, we put x equal to 1 and y equal to m. So wherever you see degree 3 terms, put x equal to 1, y equal to m. So that means we are going to get m cube plus 2 into 1 into m square plus 1 square into m. So this will be our phi 3. So I hope you understood. Phi 3 means find the third degree terms, put x equal to 1 and y equal to m. So m cube plus 2m square plus m. Now comes phi 2. Phi 2 means you have to find second degree terms. Degree 3, degree 3, degree 3, degree 1, degree 0. There is no second degree term. So automatically phi 2 becomes 0. Now phi 1 means degree 1 terms. Now degree 3, degree 3, degree 3, degree 1. There is only one term. Okay, anyway, I found the term. Now what should I do? I have to put x equal to 1 and y equal to m in those terms. But there is only one term. So basically, it will be minus m. Yeah, so phi 1 is minus m. Now, look at this. We have three equations. Using these three equations, you have to find the values of m and c. Okay, now look at this. We found phi 3, phi 2, phi 1. Now what we do is, we will start using the equations I gave you at the last. So the first equation is phi 3 is equal to 0. That means m cube plus 2m square plus m equal to 0. You can solve using your calculator, or you can take m common and write 2m plus 1 equal to 0. So I get three possibilities: m equal to 0, m equal to minus 1, minus 1. Okay. Now we go for the second equation. Second equation is c by 1 factorial phi 3 dash plus phi 2 is equal to 0. This is the second equation. And that will be like c into, what is the derivative of phi 3? Phi 3 dash means derivative of this. So phi 3 dash will be 3m square plus 4m plus 1. 3m square plus 4m plus 1. 3m square plus 4m plus 1 plus phi 2 is 0, so plus 0 equal to 0. Now that means if we put m equal to 0, the first value, we will get c into 0 plus 1 is equal to 0, or rather c equal to 0. Okay, so m equal to 0 means c equal to 0. And by the way, if you put m equal to minus 1, you won't get anything, because you will simply get 0 plus 0 equal to 0, because if you put minus 1, it's going to be 3 minus 4 plus 1. See, you will get 0 plus 0 equal to 0. So time to write the next equation. Second equation is the third equation is c square by 2 factorial phi 3 double dash plus c by 1 factorial phi 2 dash plus phi 1 equal to 0. That is c square by 2 into, let's go for the second derivative, phi 3 double dash will be 6m plus 4. So in bracket I'll write 6m plus 4 plus, I know this value is 0, plus phi 1 is minus m. Okay, now we'll try. We'll put m equal to minus 1. So c square by 2 minus 6 plus 4 minus 1 is equal to 0. That means c square is equal to 1, c equal to plus or minus 1. Yeah, that's great. That means m equal to minus 1 gives c equal to 1 and c equal to minus 1. So now look at this. We assume the asymptotes to be y equal to mx plus c, right? So let's plug in the values. So the asymptotes are y equal to minus 1 into x plus 1 and y equal to minus 1 into x minus 1. So that's it. We get three asymptotes. First asymptote we already found here, the horizontal asymptote. The same result came here. You can notice that 0x plus 0. And the second asymptote is here, the third one is over here. Okay, let's try one more question in this video, and the remaining questions I'll try to put it in the next video. So please write, find the asymptotes of x cube plus y cube minus 3axy is equal to 0. So what is the first thing to do? Inspect term by term to find the degree. So the degree is obviously 3. Now second thing to check is x cube term and y cube term. Okay, x cube term is present, y cube term is present. That means no horizontal asymptotes, no vertical asymptotes. So the only hope is oblique asymptotes. So let's go for it. Let y equal to mx plus c be an oblique asymptote. Now look at this. What are we going to find? Phi 3, phi 2, phi 1. Phi 3 means, I'll circle it for you, degree 3, degree 3, degree 2, so I'm not taking that. So I have to put x equal to 1, y equal to m. That will be 1 cube plus m cube. Now phi 2 means degree 2. There is only one term of degree 2. I'll put some other color. Oops. Okay, so x equal to 1. So 3a into 1 into m. And of course that negative. And there is no degree 1 term, so it is 0. That's it. Now the game starts. So the first equation is phi 3 equal to 0. That means m cube is equal to minus 1, because 1 plus m cube is 0. So m is equal to minus 1. Now the second equation is c by 1 factorial phi 3 dash plus phi 2 equal to 0. You have to by heart this equation. There is no other shortcut. So c into phi 3 dash. Phi 3 dash means 3m square plus phi 2. Phi 2 means, okay, minus 3am is equal to 0. Now let's plug in m equal to minus 1. So 3 minus 1 the whole square. So 3c plus, so we get c is equal to minus a. That's it. We got m and c. So the required oblique asymptote is minus 1 into x minus a. Yeah, let's try one more problem, a very special question. Find the asymptotes for the function. So I'll go a little bit fast. The degree is 4, degree is 3, degree is 3, degree is 1, degree is 1, degree is 0. Okay, so inspection done. I'm going to declare degree of the expression is equal to 4. Now, x power 4, y power 4. X power 4 is missing, y power 4 is missing. That means horizontal asymptotes are present, vertical asymptotes are present. Now tell me, how do you find the horizontal asymptotes? Very easy. You go for the highest degree terms in x. You go for the highest degree terms in x. I'll do one thing, I'll underline with red. Okay, I can see that highest degree term of x is x square is here, x square is here. The remaining are smaller degree terms of x. Now look at this. The coefficient is y square. The coefficient is minus y equated to 0. That's it. This is the combined equation of the horizontal asymptote. Now if you want to split it, you can do like this. So the horizontal asymptotes are y equal to 0, y equal to 1. To find the vertical asymptote, you have to go for the highest degree terms available in y. Okay, I can see y square. I can see y square. The remaining part is like what you call smaller terms in y. So, the coefficient of y square is x square minus x is equal to 0. So, this is the combined equation of the vertical asymptotes. That is x into x minus 1 equal to 0. That is x equal to 0, x equal to 1. Okay, so we found 4 asymptotes. 1, 2, 3, 4. Wait a minute. The total degree is 4, right? The total degree is 4. So, the number of asymptotes can never exceed 4. That means there will be no oblique asymptotes in this example. Okay, so that's it. Now let's try one more problem, a very simple one, that is x square by a square minus y square by b square equal to 1. Anyway, I'll put it in the proper algebraic form. I'll take LCM. I'll multiply throughout by a square b square, whatever. I'll end up with a square y square minus a square b square equal to 0. Okay, now inspection, degree 2, degree 2, degree 0. Remember, a and b are constants and constants have degree 0. So, I'm going to declare the degree of the expression is equal to 2. Now, x square present means horizontal asymptote absent. Y square is present means vertical asymptote is absent. Now, that means the only asymptotes present are oblique asymptotes, if asymptotes are present. So, let y equal to mx plus c be the oblique asymptote. Now, what should we do? Phi 2. Phi 2 means inspect degree 2 term. Okay. So, there is a degree 2 term here, degree 2 term here. So, I have to put x equal to 1. So, I am going to get b square minus a square into y equal to m. Now, phi 1 means degree 1 term. There is no degree 1 term, 0. So, that's it. Now, what we do is we write the relations. What is the first equation? Phi 2 equal to 0. That is b square minus a square m square equal to 0. We just found phi 2, right? And that gives me m square is equal to, just take it to this side, that side, b square by a square. So, m is equal to plus or minus b by a. Now, the second equation is c by 1 factorial into phi 2 dash plus phi 1 is equal to 0. That is c into phi 2 dash means what will be the derivative? 0 minus a square into 2m minus 2a square m minus 2a square into m plus 0 equal to 0. And when we plug in the values of m, we can see that c is equal to 0. So, look at this, y is equal to mx plus c is the required equation. We found m equal to b by a and minus b by a. Whatever we plug in here, we get c, the response of c is 0. So, the answers are y equal to b by a into x and y is equal to minus b by a into x. That's it. 2 oblique asymptotes. Anyway, I'll wind up this video right now, and I'm sure you got a rough idea how to calculate the asymptotes for an algebraic function or a what you call implicit function. But this is not enough. Try a lot of questions from your books and the past paper questions. So I'll be back with another video very soon. So till then, my friends, bye.